Welcome to our Week 9 materials for Industrial Drawing 20A. The theme for the week we can see is isometric drawings. And actually isometric drawings are one of the three kinds of pictorial drawings that we talked about. If we look at our class materials back from the INDRB 12 class, the Week 4 materials talked about pictorial drawings. So you've seen isometric drawings before. Isometric is a form of pictorial drawing. Here's isometric. Isometric drawings are supposed to look like 3D objects, even though they're only drawn on 2D paper with simple lines. They're not really 3D, but they have that appearance. And then what we do is we figure out which system of pictorial drawing works best for the purposes we have. Understand that everything we've done up to this point, though, really in this class has been a mechanical drawing, one view, two view, or three views in engineering format. This is an example of a flat one view drawing, of course. And then here we have our multi-view drawing, three views with hidden lines, center lines, one object, but three different views of it. We have an architectural drawing here showing some irrigation, same idea. Outline of the house, but we're looking directly down on it. It's a flat view. Here are a couple of more multi-view drawings for a mechanical object or two. And then even our cabin drawing, of course, is a plan view. It's looking straight down at something. It's not looking at it from the exterior. It is a drawing intended for fabrication and construction. So we're going to talk about pictorial drawings because even though we've made a lot of those engineering format drawings, we do need to be familiar with pictorial drawings. So here's some information from the B12 class that you might remember, or this might be a good refresher for. Pictorial means like a picture. So we're drawing things as they would appear if we snapped a picture of them. For example, this large house is not drawn from the top view down like a plan. It's not drawn from the front view directly toward the front door like an elevation. It's actually drawn as if we were standing outside and just looking at it. Here's another pictorial view of an object. This is a potting bench or a island countertop, a butcher block maybe, in a kitchen. Again, it's drawn as if we can see the front and the top and the side all at the same time instead of in three individual views. This cap screw is drawn in a similar fashion. It looks like we're holding it in our hand and looking down on it. And even this 3D rendering here of this box cutter, not flat views, no hidden lines, simple. What does it look like when it's finished? What would it look like lying on the table? These are pictorial drawings. So pictorial drawings have a special purpose. First of all, they're not intended for fabrication because they don't show the exact shape or the exact sizes of objects. Pictorial drawings are very useful when you're trying to show or instruct somebody who doesn't have a technical background. So somebody who you're trying to get to invest in a project, or someone that you are having do sales for a project, or somebody that you're just running the idea by who's not technical. You see, it's easy to understand a picture that looks like the final object instead of multiple engineering views of the object. Because pictorial drawings are supposed to be simple, some of the things that we do in engineering drawing are not included. For example, hidden lines are typically not shown on pictorial drawings. There are three types of pictorial drawings that you learned about in the INDRB 12 class: perspective, oblique, and isometric. And of course, the most difficult system for drawing things pictorially is perspective. It is the most realistic. We're not going to draw anything in perspective in this class, but you should be able to identify when a drawing has been drawn using the perspective method. Basically, here's what we're looking for. We're looking for lines or objects that recede off into the distance. Here we're looking down a roadway, and here are some light poles, and each of the light poles are getting shorter and smaller as they get down here toward the horizon. The point down at the end that everything appears to vanish at is called the vanishing point. So this is a perspective drawing. It gives the illusion of things getting smaller as they go far away from us. Here's a mechanical object. The idea is we could draw the front of it Here's the front view, and then we pick a point called the vanishing point, and then we project all the corners back to that vanishing point, and then we estimate the depth that we want and cap off the back edge of the object with some more line work. Perspective drawings are very realistic. They're very impressive when they're done well. And if you think about it, our eye sees things in perspective. If we were to draw a line here at the edge of the ceiling, and here along the edge of all the door openings, and here at the bottom edge of the wall, we would see that all of these points are converging at a point here in the middle of the wall, far off in the distance. This is another kind of perspective drawing. Instead of having a single point, though, there are 2 points. So there's a point here on the right side and a point here on the left side, and all horizontal edges are receding back to those 2 points. This is called 2-point perspective. In the past, doing this manually, there have been little tricks, like this guy's holding a rubber band. So as he pulls the rubber band up and down, you can get the different angles you need at those 2 points. In 1-point perspective, single vanishing point. In 2-point perspective, 2 vanishing points. Same object, just a different drawing method. And then finally, 3-point perspective would have a 3rd point, and this would help us to draw things from in a high view, looking down like a bird's eye view, or looking up from something, a worm's eye view. Here's our worm's eye view. We're down on the street and we're looking up at this tall building, and it appears to get much smaller very quickly as it goes up, even though it doesn't. Perspective looks impressive. The problem with perspective is if you've ever done it in an art class, I'm going to tell you right now, you didn't do it correctly. Art teachers have a decent idea about how the system is supposed to work, but they don't take the time to make it perfect. And if you take the architecture classes here at Bakersfield College with Mr. Anderson, well, he will introduce you to the pain of perspective drawing. To properly do a mechanical perspective drawing, you've got to take your plan view, your top view, and you got to take your elevation or your front view, and then you've got dozens of points to project and locate in order to create that perfect mechanical perspective. It is a ton of work. Even for this little set of stairs here, we're looking at lots of lines and lots of projection. And honestly, for what we're doing, it's just not worth it. Here we're even doing the shadows in perspective. Again, lots of projection and planning and line work. So while perspective gives you the most realistic view of an object, it is also the most difficult system to do properly. It is not necessary in industrial drawing to create things in perspective. So what we're going to do instead is we're going to focus on an easier method for creating pictorial drawings. We're going to talk about a system called oblique. Now, while oblique is much easier to do, the drawback is it gives you the least realistic images.